Now we're going to jump into automation, and we've got a similar format to automation here in that we're going to have some information from AJ, and then he's got a few people lined up to talk about some things they're doing. So I'll hand it off here to AJ, and here we go.
Yeah, hi everybody. Let me share my screen here. Hopefully you can hear me.
Yep, sounds good.
Good. Okay. So I'm not actually sure if we'll get Daniel to be able to talk to us a little bit about it. Can you guys also see my screen?
Yes.
Cool. All right. So I'm AJ Ragusa. I'm the manager for the network automation and performance team. You know, there was a slide there for a quote. This is one of my favorites from Aristotle. We are what we repeatedly do. Excellence, therefore, is not an act, but a habit. My band director back in high school drilled this in, so I thought it was a useful quote to put in there. It's kind of how I approach a lot of things. I'm going to just mention here really quick all of the parts of the current GlobalNOC network automation tool stack and kind of what they do. And then we'll go into the much more specific GlobalNOC parts. So a lot of what the GlobalNOC tool set is built around AWX, Ansible, GitHub, Jinja 2, basically a bunch of open source tools and technologies that people can use. And so AWX and Ansible really are kind of that core part of the tool set. It lets us do playbook execution, template renders. We have our custom playbooks to help with other automatable tasks as well. So for example, Ocean has been using AWX to do Cisco device upgrades, like to upgrade the software on the devices. Then we have GitHub. So again, it's just Git. We're using GitHub because it provides a nice web UI and a lot of extra features like, obviously there's a lot of authorization stuff built in. You can kind of go to a nice web page to browse it. It's got webhooks and other capabilities that are really nice to have. So we're using that, and that's where really all of the kind of core of the tool set starts. So basically, AWX is just launching a bunch of playbooks that exist in GitHub that render templates and store the results in GitHub. So we have a fully versioned history of what the network device configs look like over time. So that brings us to NAT, which is GlobalNOC Network Automation Tool. And basically, this is just an integration of GRNOC-DB, GitHub, ServiceNow, and AWX. So instead of having to go to each of those tools kind of individually to do each thing that you want to do, the NAT tool kind of integrates everything together into a one-stop page where you can basically go and start the entire workflow process. Another tool that we're using is Yang, which stands for Yet Another Next Generation. So obviously somebody ran out of naming things there. And this is basically just a modeling language, it basically just lets us describe what this model should look like. And then that's where the GlobalNOC Service Configuration System, or GSCS, comes in. This basically takes those Yang models and will render and display them on our web page. We also then can do validations. So for example, we can say, hey, the MTU must be between 1500 and 9000 or something like that, or must be a valid IPv4 or valid IPv6 address. So we can stick all those kinds of validations in, render it, and then make sure that the user input actually matches those validations. We've also done a bunch of stuff to extend what the default Yang models can do. So that way we can do things like web integrations, for example. So our Yang models have the ability to kind of say, this is going to be a drop-down selector. And when it's a drop-down selector, you can go fetch this information, say, from GRNOC-DB. And so that's how we can do things like, hey, what node do you want this on? Once we know the node, we can then say, okay, well, what interface on this node do you want? And we can start doing all kinds of additional input filters and validations and stuff based on data that the user selected. So that's kind of what the stack looks like today, or at least the base components. So I've tried to include some screenshots of different things here. So again, AWX, Ansible, Jinja, GitHub, and GlobalNOC DB. These are kind of all that core set of tools that the automation system is really built around. So the bottom left corner is the AWX dashboard. You can see, just basically how many jobs are being run, how many fail, total number of hosts, inventories, all kinds of details there. The nice part is if you are one of our network automation customers, you don't have to worry about AWX really. Like, it's available to you, you can access it. But if you're just using the NAT tool, it will do all of the stuff for you. So the middle screenshot is just an example of one of the actual rendered config chunks that's then stored in the GitHub repository. And then on the right is actually, for example, how we can go fetch information from GlobalNOC DB and then render it to include a different set of templates based on information that we've pulled out of the devices. So we can do all kinds of different rendering and template-based things using data from GlobalNOC DB or user input or whatever it is that we need to. So then that brings us to NAT. So this is, like I said, this just provides a web UI for launching the automation workflow. When we talk about NAT, generally, we're not talking just this web page and services behind it. We're talking kind of that entire stack. So AWX, Jinja, GitHub, GlobalNOC DB. So all of that is really part of the NAT tool. And this is mostly meant for configurations that are the same across devices. So this could be, say, your NTP configuration, syslog, or authentication. So it's not meant for things like we can do some amount of templating in there to change things. So for example, maybe based on the region that your node is in, it wants a different syslog server. We can actually template that in to via Jinja. But it's really meant for things that are going to be the same. The GSCS tool is for things like, well, on this interface, I want this description, because that's more of like an individual service at that point. And again, this integrates with a bunch of different aspects of the automation suite and other GlobalNOC DB tools, and we're hoping to continue expanding this, right? So right now, it's got direct integration with AWX, GitHub, ServiceNow. Basically, we can require a change ticket for you to be able to actually deploy a change, and GlobalNOC DB for things like lists of nodes, what their current statuses are, all that kind of stuff. And one of the new things is that NAT is actually utilized by the GlobalNOC service configuration system to actually push those service changes to the devices. So basically, NAT is kind of like that first stage, and GSCS kind of is the layer on top now. And we have a lot of different new features that we've been adding in, and I'll get to those. Basically, we have like individual, partial, and full node network deployments. And batch updates are some of the new features that have, I think, been really utilized well, especially by the nWave team, as they've deployed a bunch of almost, I think it's 100% or close to 100% of their devices. I think it's like 396 devices when I last checked that they were able to push out the base configuration for to meet some security requirements. The other thing is that we do have a multi-vendor support. So, Juniper, Cisco iOS, Cisco iOS XR, and Aruba support at this time. So this is just a really quick, a few screenshots of what the GlobalNOC Network Automation tool looks like. Basically, it's supports multi-network kinds of things. So let's say iLight and Indiana Gigapop. So you can select which one of those you want to work off of. It integrates with GitHub by being able to pull a list of branches and then being able to let you select which branch and then do some action on it. There are generally two actions. You can do render, diff, and create pull requests, or you can do diff and deploy. So the idea there is that you would create a branch in NAT, you would make some changes to a template, and then you would go through and you would create a render of it, you would diff it to the actual network, make sure everything looked good there, and create a pull request in GitHub, which is basically how your change would get pulled into master. Once you have a valid pull request that you can pull into master and people have reviewed it, or whatever other pre and post checks you need to do are done, you can then do the diff and deploy, where it'll do a diff, show you that diff, and then basically say, are you ready to go, and push this out everywhere. You can see that there's a ticket field, so where you actually have to go in and select what change ticket you would like to actually deploy this with. You get to select which devices. So instead of deploying it on all the devices at once, maybe you want to test it out on 1 or 2 less critical devices before you push it out to, say, all 400 switches. And then you can put in a description and you put in your Git token. The one on the right is actually showing you how we can now do batch-based confirmations. So you can actually go in here and you can say, instead of doing all of them at once, I want to batch update and say, I want to do 25% at a time. So you can batch it in those 25% increments, whatever that might be for your network. And then you'll be able to confirm the entire batch at once. When there are 300 devices to click confirm batch on, I think the network engineers got a little annoyed with having to click the button every time. So that's just some examples of things that we've tried to do to make the tools easier for people to use. So that brings us to the GlobalNOC service configuration system. So GSCS's goal is to configure these individual services. And I think you've probably heard several presentations this user group meeting talking about how we're doing more with services. There's the N-Wave notification services, Dan's utilizing services in the portal. And so I think this is just another aspect where we're starting to move more towards services in general. And so what we're talking about when we say a service in GSCS is really something that you probably provide to a customer. So maybe it's a connector or an R&D peering or a commodity peering, something like that would be a service. And so what we can do there is instead of having to think about the configuration for, let's say, a BGP peering where you have to create a unit, you have to add an IP address to that unit, you also have to configure the BGP peering and the prefix list, and whatever other kind of policy rules that you need to apply to it. We try and think of it, all of that now, as one single unit for whatever that type is. So if it's, an R&E peering, you maybe have to add some special community tag to it. Well, the idea here is that the network engineer that's configuring that only has to make the decision as to what type of service is it that they are deploying or editing. After that, they get a form that hopefully just walks them through the basic information, such as, oh, okay, you want to set up this new connector. Well, you have to select an entity, you have to select the port you want it on, and everything else then just happens through the system by being able to talk to GlobalNOC DB and other systems to make a bunch of decisions for you. And a lot of those are still overridable if the user wants to, is essentially the idea. So once the user has completed the form that's needed for the configuration, GSCS then uses the NAT tool to actually push that service-specific configuration into the GitHub repository and into the device configuration itself. So GSCS is pretty much just this web UI for modifying and storing the service data. Once you use it, it will then basically push its data back into the NAT tool, so that way your device configurations going forward will have that configuration. So this is a really quick, I've got a few different examples here. So this is this is the service that we've set up for the GlobalNOC VPN service. So a lot of our customers who are using GlobalNOC VPNs, hopefully will be able to configure your VPN service via GSCS very soon. So on the left side here is the actual user form that gets filled out. Again, a bunch of this information is getting pulled in from GlobalNOC DB. So once you select a router name, for example, it will then display a list of interfaces. And so you get to select that interface, you can select a type, all kinds of information like that. Then you have to enter some amount of IP address information to complete our VPN. This is me just filling in a bunch of random IP addresses, so none of this is actually used. And then on the right side here, this actually gets rendered into your device-specific language configuration. Where possible, this language dropdown also changes to OpenConfig. So where it's possible, we try and integrate with OpenConfig as best as we can. So that way, there's less work to be done in the future to support those kinds of open protocols. So a lot of things you can expand and see the actual open configuration details if you need to, and then you can make really more custom changes that we hope you don't have to make, but are possible if you need to. One of the other things that we've done is we've integrated GSCS directly into GRNOC DB. So if you are in the services section for a service that is configured in GSCS now, you'll notice that there's now this configured in GSCS and configure in GSCS option that pops up. So this is actually how you get to the GSCS tool now. You'll basically go from the service in GRNOC DB, click the actions button, go to configure in GSCS, and that will pop you right into the page for that service's GSCS configuration. So, this way we're trying to pull all those things together. So you'll have, monitoring, notifications, portals, and the configuration now all based in that services section. So there's two things that I've kind of talked about here, and this is kind of going to show the progression of kind of how these things kind of work. So for example, this is a Jinja 2 template on the left. So you can see that there are, there's a bunch of if statements and stuff, but ultimately this just results in things like a description, which is replaced by some configuration detail that we've passed in. On the right side, for example, is the start of one of our Yang models. So you can actually, these are, Yang is a very extensible language. We can create all different types and properties that make it so that way we can do very complicated models that then do have support for, validation essentially. So, this is the GSCS render form, and this is the completed template. Okay, so so that's kind of what the tools are. I was just going to talk a little bit about kind of where we started. So in 2018, we kind of had a proof of concept at supercomputing. It was Ansible plus some playbooks, just modifying device configurations. It utilized a lot of GitHub pull request kind of stuff. And then, basically we started playing around with it more as we wanted to make it more usable, more actually something for customers to use. And we started playing with AWX in 2019. And this allowed us to do a lot of interesting things like centralizing playbook deployments. We were able to utilize web services instead of CLI calls. And it, by giving us these web services, it made it possible for us to then create the NAT tool, which basically was that centralized web UI, kind of for workflow management purposes, right? And then we were able to integrate it with ServiceNow and AWX. But when we first did that in 2019, we only had Juniper support. But then once we had this, that was when we started thinking about, okay, well, this is great for how we do, things that are the same across all the devices. But now what do we do for these individual services that are going to be different everywhere we go? So, basically where we were last year, we had a NAT 2.0 release, and this added a bunch of support for different device types like Cisco iOS, iOS XR, Aruba, Arista. And we also added in things like the ability to detect sync problems between the network and what we call master and GitHub. And so this would be, for example, hey, a user logged in, or well, one of our network engineers logged in and made a change to a device that is now not in sync with the rest of with what the NAT tool says it should be. And so we can actually now create alarms on each device that basically says, hey, this is out of sync, here's what's out of sync, and require a user to go in and fix it. We also started adding in the ability to do custom pre and post checks for each network workflow. So before we do an actual push to the devices of a configuration change, we can do some kind of pre-flight check And maybe that is just gathering, hey, let's grab all of the BGP tables and just give a rough count of what those peers, what the counts are for established peers. And then post, we can do something that says, okay, grab that same number now and compare them. And if there's more than, say, a 1% variance, we can roll back that change. Or we can signal a flag that says, hold on, somebody needs to look at this because something didn't happen right. Last year, we also had our kind of initial proof of concept for GSCS. So again, this is utilizing Yang, OpenConfig, MongoDB in the backend, which is how we're storing all of the data, and React Web UI. And we kind of had the rough proof of concept. It wasn't really ready for people to use, but it was kind of where we were able to start saying, hey, this is how we want to go forward. And so we also, at the same time, we had to have something to load in there. So we started with some per service type Yang models using OpenConfig and Jinja 2 to create and store these specific applications. And we did have a GSCS 1.0 release where mostly ready for production, where we can start putting it on customer installations and start working with customers to enhance the Yang models and get the features that we needed. So where are we now, let's say, with GSCS? We've had at least 3 production releases. I think actually the 4th one is being rolled out this week. Basically, we've been adding a lot of support for features that the customer services have needed. So we thought we had a pretty decent feature list, but as we've been getting into the nitty-gritty details with the customers, we found a few things we needed to do. One of the things that we started on is what we call the GSCS beautification project. So you've probably seen from the screenshots that there's a bunch of forms and stuff to fill out, but it's not really pretty. So we've been trying to work on improving the UI in many aspects. Less white space just being everywhere. And giving lots of interesting capabilities like tooltips and embedded CSS into the Yang model. So that way, people can actually we'll have enough tooltips and other documentation available that network engineers who don't know much about the tool should be able to complete their work without needing to either ask somebody who knows about the tool or ask the NAP team how to do it. Integration, obviously, directly into the GRNOC DB services section. That was important because we wanted people to be able to access the tool straight from GRNOC DB and not have just treat it kind of like it's almost a part of GRNOC DB, not like it's its own separate thing. Direct integration with NAT was a little bit more complicated than we had initially anticipated. And then, like I said, that integration of tooltips and CSS into the Yang models, which is going to give us the ability to do a lot more styling and informative kind of inline documentation with the models and how people use it. So currently, we've been working on 2 GSCS models and templates, and they're almost ready to go. So the GlobalNOC VPN service for the iLight Indiana Gigapop team is just about ready. The Ocean eVPN service was the first one that they had decided to go with, and so we have that one. I think once we have this next GSCS release out, they should be ready to go. And the other thing that we've done is we've done a lot of work making sure that we can integrate external JSON-based web services. So GRNOC DB is one, but we can also do things, say, like RadDB or other IRRs or whatever other external kinds of data sources that you guys want us to pull. We should be able to integrate those now into GSCS fairly easily. So that way you guys can, say you want to pull in the prefix list from a customer automatically. We can do that. We can even make them update automatically, say once a day or something like that. We can do that to validate, use our prefix list or something like that. So we've been working on those kinds of extensions for GSCS. On the NAT front, this is where we've actually had the most uptake from customers. And so there's a lot going on here, mostly as feedback. So we had a lot of feedback from the NOAA guys. So Daniel and Sean, thank you guys very much for that. So we've been able to pull a lot of additional data into GRNOC DB, specifically into the templates. things like management addresses and gateways, IPv6 address integration, all those things that the data exists in GRNOC DB, but we wanted to be able to, build the entire, some entire portions of, say, the system config on a Juniper. And so we were able to do that with management addresses and gateway stuff that exists in the IPAM section of GRNOC DB, for example. Obviously, all the new device support, Arista, Aruba, Cisco iOS, iOS XR. The batch mode stuff, I think, was very important for the nWave guys, especially the services team. As I said, they got like 390 devices. And so they couldn't really do all devices all at once. That would probably have been very challenging to do. So we first came up with the batch update mode, and then we added in the batch confirm commit mode. So I know that those guys were very appreciative of that. We had the per device synchronization manual edit Nagios check. So basically the ability to say, oh, this device is no longer in sync with the rest of our network. ServiceNow change ticket integration was, it was relatively easy to do into NAT, but I think that provides some interesting functionality for people going forward. If you want to push a change into the network, you have to have an approved change request, for example, something we can do. Performance improvements. So this again was the NOAA guys that really, we had to go figure this out. We had an over 1,000 times performance increase. So it was taking like 2 days for them to be able to just render their entire network. And now we've got it down to, 2 minutes, I think is what it takes to render their entire network. So that was a very important change. And diff and also the deploy were also made that much faster. So we are now, they can now push out a lot of changes very quickly to all their devices if they needed to. We also added a bunch of status filtering. Not everybody has all their nodes active. Some people have them in install or test state or in a planning state. And so the problem was the tool would try and push out device configurations to these devices that weren't ready to go. And we didn't want that to happen. So now you can filter and say, I only want to do this to active nodes in the field, for example. And a lot of improved error handling, trying to get better errors that the user can actually make heads or tails of without having to come back to the NAP team all the time for details as to what's happening. And one of the last ones that we've been working on is better handling of conflicts inside of Git. This one was kind of painful because basically when we build our rasterized configuration, stick that in, that would cause conflicts between different branches. And so we had to figure out a way of handling those conflicts, especially for, again, the nWave guys who are having hundreds of devices, and those conflicts would take a long time for us to manually resolve. So we've been able to automate a lot of that conflict resolution inside of the tool itself. So kind of what we've been working on, again, I've talked about the services and the tooltips and the GSCS beautification. I think we're really ready now to really start with the external sources like RADDB and IRRs. So as we get more services going for customers, I think, taking a look at how we can integrate these external data sources in is going to be very important. As well as making the usability of the tool much better. So that's where the GSCS beautification project comes in. So just a few of the things, examples of what we've been talking about, right? So we've got the tooltip embedded into the tool. So this is in the next GSCS release that should be coming out very soon. We also have the ability to embed CSS in. So this is just an example where, hey, we embedded CSS for this widget. We can change it. We can change this color, but we can do any other number of things as well with it. It doesn't have to be just color. So we have all this. We have a bunch of functionality now that we're going to have to figure out how to take advantage of. This is how we actually integrate it into the NAT tool. So this is basically you put your Git token in and a description, and it's going to automatically just figure out a bunch of other things. We can also require, for example, a change ticket. So like I said, one of the nice things here is the customer usage is picking up. nWave Services has deployed, I think, 100% of their devices. Daniel can correct me if I'm wrong. And I think one of the best parts for me has been that they provided a ton of great feedback, and that's really helped us improve the tools. So I think we've tried to be really responsive to them as they were using it. I know the N-Wave transport team is also using that to update the passwords across all their devices. It's about 50 devices, but having a standard workflow to follow with that, I think makes their lives better. They also are getting a lot of experience using the tools, so I think that's good. So Ocean has used AWX to push out device software updates across their new network. There is a little Cisco bug that's been preventing them from fully working with that, but we've been able to push forward some with them. The iLight Indiana Gigapop guys are just about ready to use GSCS to push out the VPN configurations. We've been just working on those final nitty-gritty aspects of their model and templates to get that going. And Indiana University just started using the tools. They're starting with the base configuration for both the edge and the core, so that should be pretty neat as well. The edge side has a ton of devices, so I'm interested to see how we scale at that level. And then, like I said, that Ocean EVPN model is just about ready. I was hoping we'd have it ready this week, but we just keep running into little tiny things that we've been improving. So one of the interesting things here is thinking about how all this fits into kind of GlobalNOC's roadmap and priorities. Basically there's a bunch of different automation things happening inside of the GlobalNOC, and a bunch of the tools here are helping support that. So, I think you guys have heard about the syseng automation position that we have, and then basically GlobalNOC automation in general, not just network device config stuff. And both of those will probably be leveraging AWX and Ansible fairly heavily. And some of those might also end up utilizing network device config automation as well. So that might be things like being able to do some automatic troubleshooting or diagnostic capabilities. Then there's also the service-based notifications and monitoring. Well, obviously, if we can also push out the device configurations, that'll help even more be able to do all of this kind of integration stuff more directly into all the tools. Then the question is, well, what's coming for network automation? So there's a lot more training we need to do. GitHub is kind of one of the cores of our services, and we really want the engineers to be self-sufficient and be able to do different things with its processes and capabilities. Then there's also Ansible and playbooks. I know a device config is a large amount of what the network engineers do, but there's so many other processes that they have that are not just config related. And so giving them the ability to create their own playbooks to help them in their own, basically do their own daily tasks will be very important. So that way they don't have to ask us to do everything. They'll be able to do them on their own. So training on those two aspects, I think, will be extremely important in the upcoming year. Obviously, we want to do more GSCS services. We've already started on a second Ocean Yang model, and hopefully we're soon going to be starting on some N-Wave models. And one of those last things that we want to do is start sharing Yang components, models, and templates across GlobalNOC customers and eventually the R&E community. As a lot of the stuff that we're doing is open sourceable enough that we can share several aspects of this with other people in the community. So we do have some other future planned tools. So more workflow, ServiceNow kind of integration things. I could imagine we haven't really figured out where we're going yet, but you have a new customer, so being able to fire off a new customer workflow that not only that adds stuff to GRNOC DB and then creates the GSCS service and pushes that configuration out, being able to do that all in kind of one workflow instead of having to kind of hit all these individual tools would be a very great thing to do, I think, for all of our customers. And that would also potentially mean quicker turnaround times for some requests, right? Maybe we can pull some information from ServiceNow and based on that ticket, oh, it's a prefix list add. We can just go right into the service from ServiceNow and add that prefix without having to go look up a bunch of information. And the other one that I think will be very interesting is the visual Yang and template builder. Basically something to help people, network engineers specifically, be able to build their own Yang models and templates that go along with them, and then be able to upload them into the GSCS tool. So that way they don't need to rely on the NAP team to go back and forth with them constantly on building and modifying their models. They'll be able to modify them, create them, and basically administer it on their own without having to rely on our expertise to do this, basically making it more self-service. And then the last one, I think, is providing custom end user, i.e. for your customers, tools to allow them to update certain aspects of the services you provide them. Maybe something like prefix list updates, VLAN changes, whatever services you guys offer, things that might be interesting for them to be able to change or control. So that's what I've got. I don't know that Daniel will have much to say. Daniel, if you're around, or Adam, or anybody from the N-Wave team.
I am around, AJ. So I think you covered quite a bit, and you know, a lot of the stuff that you've been working on with AWX. And I remember when we started this, I think it was last year, you know, getting AWX on the N-Wave network, and then, you know, getting the N-Wave team kind of working in it. Those early stages were really hard. There's a lot of bugs, like permission issues, things like that. But we're at a current stage now where we feel pretty good, and we have like a nice roadmap. And for the GNAT tool, we've, you know, there's a lot of issues in the beginning, but, you know, we worked through them and it's pretty mature now.
So Corey, I think that's all that I've got, unless there's questions or.
I think we open it up for questions. Are there anything that other people want to know about automation? Any questions that you guys have on AJ's presentation, where we're going, et cetera? Okay, cool. If you do have a question about automation, you can feel free to reach out. AJ's got his information up there. I can help get you guys in contact with AJ as well if you have any questions. You know, just kind of let us know and we'll help out where we can.